too long.
Barber in Ireland are body number 1.
Yeah, I don't go to the barbers, I go to the hairdresser. You know, not many men go to the hairdressers, but when I was in there yesterday, it was me plus one other man, the rest were women getting their hair done. But I don't like going to the barbers because I think they cut too much off. You know what I mean?
For me,
Yeah.
they don't cut too much. Number 1. Just get you like trim with it on.
Yeah, if that's all they're going to do, you might as well do it yourself. Yeah, but hair like that, surely you don't go to the barbers. No, you go to hairdressers.
I don't go anywhere.
So how do you take care of it? Or you haven't gotten your hair cut yet here?
No.
No, alright. So it doesn't grow that fast?
No, it's been, what, 6 months now? It was like in shadows when I came, or just a bit longer.
Was it?
Yeah, it was. Just a tad bit longer.
Goodness, I'll need to see an old picture of you on Facebook or something.
Before you, like, no, I mean, the beginning of the semester, it was like, a bit. No. I know, it was, no, you came.
We need pictures as proof.
When I saw him, his hair was like, no, it was way shorter.
See, this is how I'm remembering it as well. Pictures, provide pictures. Then we'll believe you. Right, we go back to trigonometry. So you did trigonometry in semester 1, and this is kind of like continuing that. It's a little bit harder, but it starts off easy. We're just going to look at something very simple to begin with, defining some new functions called sec, cosec and cotan, or secant, cosecant, cotangent. Okay, you got that? Yes. Secant, cosecant and cotangent. Now you'll notice on your calculator you don't have these trigonometry functions on this. You don't have secant, cosecant and cotangent. At least not on most calculators. Well, good and late I see. Good and late I see. What's so difficult about 9 o'clock when you live in the same building?
That's exactly what's so difficult, because you're like, oh, I can just wake up and go to sleep.
But couldn't you pretend your subjects are important? Couldn't you pretend it's important to be here?
It is. When you're sleeping, nothing is important but
sleep. Alright. Secant, cosecant, cotangent. So firstly, the definition of secant of x is 1 over cos x, and the definition of cosecant x is 1 over sine x, and the definition, you could probably see where this is going, cotangent x is 1 over tan x. So, with the help of your calculator, let's do some simple calculations. Secant, 30 degrees, cosecant, pi radians, let's say cosecant pi over 3, and then lastly we'll do cotan, 45 degrees. So secant 30 is 2.
Root 3 over 3. 2
Oh.
root 3 over 3.
Say again?
2 root 3 over
2 root 3 over 3. Okay, and then cosec pi over 30, so we obviously need radian mode here.
4. No, sorry. What is it? Just mode 4, right?
Yeah.
0.95.
Strange. I thought it would have given it to me as a fraction.
Oh, cosec. Wait, sorry. 1 sine.
1 over sine.
Yeah, 1 over.
1 over sine pi over 3.
Same.
Yeah. Yeah. It didn't give it to you like this?
Yeah, it did. Yeah, I mean, like, same as the previous answer, sorry. 2 root 3 over 2.
But it shouldn't be.
Uh,
So it means the previous one is wrong. So why don't you recalculate the previous one? Just double check it. 2 root. They should definitely be different. No, I apologize. Apologies. I was thinking this is 30, but it's 60, so actually it should be the same. And then lastly, cotan 45 degrees would be 1. Okay. And that's 1 over tan 45. Yeah. So these are some basic calculations. Scroll down a little bit. Now, here's one I want you to try. I'll give you a little hint. Calculate sec inverse of 2, and we'll put the answer into degrees, please. And I'll give you a little hint. You will need to use something you learned in the inverse lesson. Okay, I'll give you a minute to see if you can come up with the answer here. Secant inverse 2, and there's no secant or secant inverse on your calculator. Any ideas? Possibly. But suppose I said 2.1. Actually, I will say 2.1 now that you said that. 2.1. Give up? Okay. So, you have the function y equals secant x, or rather, I should really say, you have the function secant x, And what would you like? You would like the inverse function. So you have the function 1 over cos x. Do you remember how to get an inverse function? You make y equals to 1 over cos x, and then you solve for x. So then you get cos x equals 1 over y. So that means x equals cos inverse 1 over y, and then at the end you swap x and y. So you end up with the inverse function is cos inverse 1 over x. So that means the inverse of secant is cos inverse 1 over x, which will be cos inverse 1 over 2.1. So if I do that shift cos inverse 1 over 2.1 in degrees, I get 61.6 degrees. You have that? Let me just have a look here. So we have that, we have that. Yeah, okay.
When will we get the physics, last report?
Ah, you mean the results?
Yes.
That will happen after I grade it, not before. And then that will happen after I look at it, which I expect to happen sometime soon. The good news is, this morning I moved your coursework into my to-do pile. So it's literally the next thing to do on my shelf. So it's been upgraded to pending. Previously it was archived, now it's pending. Yes. Alright. Do you have all of that? So what I want to look at now are the graphs of these functions, secant, cosecant and cotangent. We'll use degrees. So the first one we'll do is secant. Secant is 1 over cos x. And we'll use degrees. Now, I need to zoom out. Get to 360. Perfect. Okay. Can you see here? Here's about, well actually, you know what, let me actually put in the range, minimum, maximum. So we'll go from 360 to 360, and what's it, we'll go 24 intervals. Oh, that's too many. We'll go with 12 intervals. That looks better. Okay. They have asked students to draw these graphs. The good news is they don't ask for anything strange like secant 2x or secant x plus 1. They usually just ask for a simple secant, cosecant, cotan, or secant inverse, cosecant inverse, cotan inverse. So there's 6 graphs that we have here to look at. Notice how these graphs break at what angle, would you say?
120.
Yeah, I know it looks like 120, but if you follow the dots, 120 is up to here. If you follow these dots, 60 is up to here. So, what do you think this might be now? Number? 90.
Oh.
The reason it breaks is because you're dividing by 0. And if you think about it, if secant x equals 1 over cos x, this is equal to 0 when x is equal to 90. So this is broken at 90 and minus 90. And then it breaks again at minus 270 and 270. So maybe actually I'll go up in 90s instead. It might be a bit clearer. Yeah, that's clearer for you? Yeah. Okay, can you draw this in your notebook? This is for Did I say cosecant? Goodness. No, secant. Yeah, secant. So in the exam, to get the full marks, they want to see where you mark the breaks. So they'll definitely want to see these numbers. So you'll need to write these down at the right places.
Which number?
The X numbers, the 90, 180, 270, and 360. You got that? Yeah? Okay. Will I put the next one on a new graph, or can I put it on the same graph as this? I'll put it on a new graph. So the next one, that's secant, the next one is cosecant. So not much difference, except these ones break at 0 and 180, 0 and minus 180. You drew this? Yeah. Iyad? Adnan? Yeah. Okay, next one is cotan. And we'll use degrees again. This is cotan, very similar to tan, except the lines are backslash instead of forward slash. But also very similar, I said the same thing, also very similar to tan, except in the tan graph it wasn't broken at 0, it was broken at 90, whereas here it's broken at 0 and not broken at 90. It's almost like a tan graph but kind of like flipped around. Do you remember did you do tan graphs? Yeah. The tan graph, if you remember, looked like this, whereas this one is just backwards. So not as different this case, if you can draw that one. Okay, 3 more to do. Secant inverse, cosecant inverse, cotan inverse. Yeah. Okay. So, can I close this now? Yes. So the first one of the 3, we'll do one that we just did. I think this is secant inverse. So secant inverse is cos inverse 1 over x. So let me see. Secant inverse is. I think this is how you do it in this program. No. Yes. Okay, this is secant inverse. Secant inverse. Now, if you look here, I don't think this graph is stopping here. I think what's happening is it's maybe shooting up to infinity. If I just zoom, well, it does look like it's stopping, but let me think. Yeah, sorry, hang on. I need to change the range here. It doesn't have to go from, it's not in degrees now, so instead of going from 360, we'll go from like, we'll just go for the original. Where'd we go? Very strange graph. Oh, I'm sorry. I typed something in wrong here. I just realized it now. Maybe this will work. Let me just delete this. Yeah, it's not doing it the way I want. This graph is. I think I cannot make it in degrees, it's in radians, but the radian. Okay, in the previous graph, what was on the x-axis? Degrees.
Yeah.
On these graphs, because it's the inverse, the angle is on the y-axis, but the program won't give it to me in degrees. So this y-axis here is in radians, as you can see, because they're much smaller than degrees. And what you notice about secant inverse, you have no value between -1 and 1. Can you see that? So the graph is not defined between here. And you can check it on your calculator. If you try to calculate it, let's put a number between -1 and 1. So give me a number between them. We'll say 0.5. Yeah? And you see you get an error. What about -0.5? You also get an error. I have to be at least 1. So if I say 1.001, for example, then I get this number. 0.000. I get this number, for example. So this graph is not a mistake on the program. There is no values between -1 and 1. So this one was secant inverse. Just so you know, for the exam, it's the x values that they really care about on the graph for getting the marks, not so much the y values. So absolutely must have the 1 and the minus 1 as the end of the graph.
What did the x values represent here?
They're not, it's like, you know the way when you're dealing with trigonometry, you have two things. You have y equals sine x, like for example, sine 45 degrees equals 1 over root 2. So here is an angle, and here is a ratio. If you have sine inverse something equals something, then here is the angle, and then here is the ratio. So angle, or the angle could be on the y-axis. In this case, the angle's on the y-axis. So what's the thing on the x-axis called? The ratio. Now, when you think about this graph, this is sec. Sec is 1 over cos. And do you remember what cos is? The definition using the opposite adjacent hypotenuse. Adjacent over hypotenuse. So the sec will be hypotenuse over adjacent. So if you want the meaning of it, this is like the ratio of adjacent over hypotenuse. So this one's the ratio, and this one here is the sorry, I said it backwards, like yes, of course. This one here is the ratio, and this one here is the angle then. Yeah. Okay, can I do the next one? So the next one is cosecant. Cosecant inverse. So cosecant inverse graph. Zoom out. So again, what do you notice about this cosecant inverse graph? Minus 1 to 1 undefined, no values. And just like the similar graph, decreases as you move out. So if I zoom out here, see it just flattens off. Kind of like what other graph you've seen. Some other graph kind of has this shape to it, this decrease in shape to the axis. Well, log is like this but upside down, so log is like a hill shape. This would be like log except just the other way around. Something else that looks like this? You're thinking the right chapter though.
E.
Yeah, but which E?
Oh, okay.
There's two, EX or E minus X.
Minus.
Yeah, minus X. So this one is like E minus X, and this one is like a minus EX. Minus E minus X or something. Anyways, these are like exponential graphs. Yeah. Okay, did you draw that one? Yeah. And the last one is cotangent inverse. Now, hang on, let me just get this right for you. Now, just to double check here, 1 over, tan inverse 1 over, yeah. Okay, so this one here, remember I said this one is angles in radian mode. I was just double checking here. This here, if you were to put this in degree mode, this is about 1.5 radians. If you were to put it in degree mode, this point here is actually 90 degrees, and this one here is minus 90 degrees. You can't quite see it because it's in radian modes, but if you just convert here, do you remember how to convert degrees into radians? 180 over pi over 180. It was one or the other. Pi over 180. So 90 degrees in radians is 1.57, which is actually exactly that number there. So at the 90 and minus 90 is when it reaches its top and bottom. Now, technically speaking, if you want to be really, really technical about it, I know it looks like it hits 90, but it doesn't quite hit 90 here. It just gets really, really, really close to 90, but just before it hits the axis, it breaks and doesn't actually reach the axis. If it did reach the axis, you would have a problem, because it means at the value of 0, you have two answers, which is not acceptable. So technically speaking, it's broken here at the y-axis. It doesn't cross the y-axis. And it looks like it doesn't cross the x-axis as well, because if I zoom out, it's like that exponential again. So this graph I think is quite interesting because it neither crosses the x-axis or the y-axis. Yeah. Okay. Now, in the exam, if you got a little bit stuck and you didn't know how to draw this, have you all seen how to use the table mode on your calculator to make a table to plot points? Or you haven't seen that?
Shift solve.
Not shift solve.
You showed that.
Did I?
What?
Let's do a simple example. Suppose I want to draw some function that is difficult, but I'll make it easy. But you know how to draw this one, but I'll just use it as an example. And suppose you want to draw it from -5 to 5. So you'd have x, y, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And what you would like are the points, so you know how high it is. You can do this on your calculator. I think it's mode table 7 in my one. You type in the function alpha x squared, press equals. My calculator gives me this, yours doesn't, so I'll just ignore. Start at -5, end at 5, and we're going up in 1 unit. And you see you have a table, so the first value -5 is 25. This is the x, this is the y. So it goes 25, 16, 9, 4, 1, 0, and then 1, 4, 9, 16, 25. So you can plot the points and then get the graph. Obviously you put the points first before the graph. It's useful for the exam. You know, in the exam, you're a little bit flustered, you can't remember exactly the shape of the graph, you can get a couple of points. Just be careful, because for these graphs, often they're not defined between -1 and 1. So for example, you would have to do maybe start at 1 and finish at 5. And then start at -5 and finish at -1. You know, you want to skip the -1 to 1 part, because it's not defined then. Yeah. Have you seen, is this new, or have I shown you this mode before? I did show it before? Really? Me or Roland?
No, it was here, yeah.
Huh? Okay. Oh yeah! Sorry, 3 more graphs which I haven't done yet. Well, I mean, I don't know if you've done them in semester 1 with Roland. You don't have to do them in semester 1, so he probably didn't do them. The graph for sine inverse, cos inverse, and tan inverse. You would have done the graph for sine, cos, and tan. So here is the graph for sine inverse. Oh yes, yeah. Sine inverse. It breaks at 1 and minus 1. Okay, cos inverse. Can I do cos now? Let me zoom out a bit. Again, minus 1 to 1. And then finally, tan inverse. I can do tan inverse now? Okay. And this is tan inverse. This shoots, this never passes 1 or below minus 1. So if I zoom out here, see it still levels off at 1. It does cross it at 0, yeah. So if you look here, Adnan, if I type in tan inverse 0, I get 0. So it crosses here at 0, 0. You have this one? Yeah. So if I look at the questions here, there's 3 basic types. You don't have to do number 3 because I've done number 3 for you. Well, I've done number 3, A to F. So if you wanted to, you could try and do G to L, but for the exam I think it's only A to F that they care about. Number 2 is practicing calculating inverses, and number 1 is just practicing calculating sine, secant, cosecant, cotangent. Yeah? Would I let you try some of these for a few minutes, and then we can start the next lesson? Is that a yay or a nay?
Okay.
I mean, do you need to take a cigarette break, or you're looking at going?
No, I just found out that
It's available, yes.
I have a couple of formulas and stuff here.
Do you want to reprint and give it to me later then?
Yes.
Just to make your life easy, I'd recommend reading through it and circling the mistakes so that when you retype it, you don't miss anything.
Mm-hmm.
Yeah. I'll be going kind of early-ish today, so if I'm not in the office, you can just leave it on my desk. If there's some teacher in the office, you can say that I said it's okay to leave it on my desk. Just make sure it has your name on it and it's stapled, of course. Yeah. Okay, Adnan, we'll take a cigarette break.